Hi everyone, in this video I'm going to go over a problem of how to find the pH at an equivalence point of a weak acid strong base titration. So this is the problem that we're going to be doing. 50 milliliters of 0.5 molar acetic acid is titrated with 0.5 molar KOH. We want to find that pH at equivalence, and the Ka of acetic acid is given. So first thing I want us to do is write our reaction. Acetic acid, which is a weak acid, is HCH3COO. And then KOH. KOH is a strong base. Strong acids and bases fully dissociate in water. That means the K and the OH fully separate. So we can just write plus OH minus. The K doesn't really matter. And so what is that going to form? This is an acid. Acids get rid of H. So the H will go with the OH. That forms water. And then the acetate ion will be left by itself. And it's going to have a negative charge because hydrogen has a charge of +1. And so if it's neutral here, it's negative over here. And let's just label again, this is my acid and that's my con base. And the hydroxide is my base. And so what do we have? We've got 0.5 molar acetic acid, and we had 50 milliliters of it. And we added 0.5 molar hydroxide to it. And so equivalence point is when moles of acid equal moles of base, and that should say M. Because these are equal molarities, the amount of base we added is the same amount, 50 milliliters. If they were not equal molarities, we would need to first figure out moles of acid, and we need to do that anyway. So 0.5 molarity, 50 milliliters, we know our formula is moles over liter equals molarity, so that gives us 0.25 moles of acid, which at equivalence point, moles of acid equal moles of base, so 0.025 moles of base. Boom. Or moles of hydroxide. Okay. Now, this reaction is 1-to-1. There are no coefficients. Everything's got a 1 in front of it. So if I started off with that much acid and that much base, I made that many moles of water, which water doesn't really affect the it doesn't affect the pH, but whatever, we'll write it anyway. And I made that many moles of conjugate base. Now, this is a conjugate base, which means it will go in reverse. And when the reaction goes in reverse, it makes hydroxide ions. Hydroxide ions increase pH. It makes the solution more basic. And so that is why the pH at equivalence is not 7, because this conjugate base acts as a base and it will make some OH. It also makes some of this acid. Now remember, this is a weak acid, so those stay together. Now we're at equivalence, so we're saying that all of this has reacted. It's gone, because that is what we formed. Like there's 0 of this and 0 of this left. This is all we have now. But as I just said, we need to figure out how much conjugate base will go in reverse. And so to do that, we're going to make an ice table. And when I make my ice table, I'm going to write this reaction in reverse. Reverse means it goes this way. So now my reactant is CH3COO minus plus water, and that will make HCH3COO plus OH minus. Okay, initial change equilibrium. Now in an ice table, we can't use moles, we use molarity. I have moles of conjugate base, but I need to find the molarity. Molarity is moles over liter. And so we need to think about what's in my beaker right now. To make that many moles of conjugate base, I mixed 50 milliliters of acid and 50 milliliters of base. So the total volume is 100 milliliters. And so to get that molarity for my ice table, I'm just going to do that down here. It would be 0.025 moles divided by 100 milliliters, or 0.1 liter. And that is 0.25 molar. So I'm going to plug that in. That's my initial concentration of con base. Now some of this will dissociate. So I'm going to lose some of that, 0.25 minus x. And when it dissociates, it forms some of those. So x. Now, we are almost ready to plug into our equilibrium expression. We're not all the way ready to go yet because this is a conjugate base. So we can't use Ka. However, we know, like for any conjugate acid-base pair, so this was my acetic acid, the acetate ion is its pair, that their Ka times the Kb of that equals Kw, which is the ion constant for water. Assume all reactions are at 25 Celsius, so that means Kw is 1 times 10 to the negative 14. So my Ka that was given in the problem is 1.8 times 10 to the negative 5. So we just need to find Kb by solving that out. And that is Kb equals 5.56 times 10 to the negative 10. So I'm going to use my Kb value for my ice table, not my Ka. And again, I have to use Kb because this is a base. It's going to accept an H. It's a base. And so let's plug in. Kb equals, it's always products over reactants. So my products are at equilibrium x times x, so x squared over 0.25 minus x. Now this Kb number is really small, 5.56 times 10 to the negative 10. So we can 5% rule this and say it's x squared over 0.25. Get rid of that minus x. And then we solve for x from here. So multiply each side by 0.25. And we get 1.38 times 10 to the 389 times 10 to the negative 10 equals x squared, square root both sides, and we have what x equals. And it is 0.0000118 molar. Now, let's go back to our ice table. What did x equal? X equals the amount of hydroxide that I form. It also equals the amount of acid. Now, this is not the same thing as H+. So that number, that isn't useful. This, however, is. I now know what my hydroxide concentration is because it gets to equilibrium. So I can't find pH first, but I can find pOH by taking the negative log of my hydroxide concentration, or my X value. And that is like 4.93. And so pH plus pOH equal 14. So 14 minus 0.493 gives us what? Like 9.07 as our pH value. So when you have equivalence point, remember equivalence point is when moles of acid equal moles of base. However many moles of acid and base you have, that's how many moles of conjugate base you make. You take that mole of conjugate base and you change it to molarity by dividing it by the total volume, and then you make an ice table. When you make your ice table, make sure you put your conjugate base as a reactant, because when the reaction goes in reverse, this is the reactant, those are the products. Fill out your ice table Now, we can't set our ice table equal to Ka. It equals Kb. So you got to find Kb by solving from Kw. Then once you know Kb, plug in, and you can get your x. And x, again, equals OH. Once you know OH, you can find POH, and then find pH. This is a big, long problem. And these take a lot of time. And there's lots of spots for you to make really small mistakes. So be very careful. And I hope this video was helpful.